Different person. NBM. I thought it was Katie. It's Kate.
Oh, okay. I figured it was like a lot.
Okay. It's not me. It's okay. Never mind. I'm so sorry. I do.
All right, so we got our calculators out. And we are going to do a couple of different things. First of all, we need to know, just in general, how to get matrices into our calculators. All right? So let's start there. All right, so here's what we're going to do. We're going to go ahead and put this in the context of a problem because we have short periods and a lot to do. So I'm going to put an equation up here, and we're just going to go through the normal procedure of solving this system of equations using the inverse method. Okay? So we are going to use the inverse method on our calculator. We're also going to be able to do that by hand, but we're going to do it on our calculator to solve this system of equations.
4 minus 7.
All right, let me make sure I copied it right. Okay. So, all right, everybody paying attention now? There's a lot of chat this morning. All excited. Oh, want to remind you, by the way, that if you want to take a prom picture with your Precal book and bring me the print, notice I said bring me the print. Do not email it to me. Bring me an actual picture like this that I can put into a collage and hang on the wall. That will be worth some points for you. Okay. All right, so here's what we're going to do. We're going to recognize that in this system of equations, there are actually 3 matrices. Maria? There are actually 3 matrices in this system of equations. There is a matrix that is just the coefficients. So there's the matrix of coefficients. I'm going to call that matrix A. Just the coefficients. Everybody see where I got those numbers? There is a matrix of variables. And then there is a matrix of constants. So what I have done is simply translate the regular system of equations into a matrix equation. Now, before you get confused about why things are situated the way they are, keep in mind that if I were going to multiply these 2 matrices together, this is a multiply, if I were to multiply these, I would take this row times this column, wouldn't I? And if I did that, I would get 1x plus 2y plus 1z, which is exactly what the equation is. So we've simply taken, just the way you normally write your equations, and we've translated it into a matrix equation, one big matrix equation. I'm going to call that A, and I'm going to call this B. Now, I want you just to think about this for a minute. You don't have to write it down because, if you go back and look at it, you might not even understand what you wrote down. But just think about this for a minute. This format is identical to an equation, an equation that looks like this. Now you're looking at that and thinking, no it's not, it's a whole different thing. No it's not. You have a coefficient times a variable equal to a number, right? Now how would you solve this equation? If you had a coefficient times a variable equal to a number, what would you do to solve that? You'd multiply both sides by 6, right? And you picked 6 because these cancel each other out. And they cancel each other out because they're multiplicative inverses. So if I multiply by the inverse of this matrix, this will cancel out and I'll have my answer. So we're going to do this on our calculator. Okay? So here's what we do. Step 1. Go to the matrix menu. So go ahead and press second matrix. Everybody find the matrix button? It's in the first column. Okay, so second matrix, everybody got it? Now you will notice across the top of the screen, there are 3 options for you. Names, math, and edit. We want to put these matrices into our calculator, so we go over to edit. Anytime you want to put info in, you need to be in edit. Okay, so just press enter. Now, I already have stuff in mine. I don't know if you already have a matrix in yours or not. But the very first, if you do, it doesn't matter. You're just going to type right over top of it. But the very first thing the calculator wants to know is, okay, you're going to put in a matrix now. How big is it? It wants to know the dimensions. What are the dimensions of this matrix?
3.
So we type 3, enter 3. And then it sets up a matrix for you to fill. So we're just going to fill them in. Now when you get the last number typed in and you press enter,
I'm having a blast.
okay, I want you to exit out, so second quit. Second quit. Now, matrix A is now in your calculator. Okay, now we need to put in matrix B. So we're going to go back into our matrix menu. We're going to click over to edit, but be careful. Now, you already got matrix A in, so now you have to go down to B. So B's highlighted now, and press enter. Now, what are the dimensions of matrix B? 3 by 1. So we put in a 3 by 1, and then we'll put in those numbers. Now, as soon as you get the last one in and you press enter, then second quit. So now you have in your calculator, hopefully, matrix A and matrix B. Now, remember our objective. Our objective is to get rid of this. So we are going to take the inverse of A times matrix A. We are going to multiply the inverse of A. Oh, no, no, I'm sorry. Let me write my equation. This is my equation. I have matrix A times my variables equal to matrix B. I'm going to multiply both sides by the inverse. These are going to cancel, so I don't need to type that in. This is what I need to type in. So, listen carefully to make sure you get this. This is what I need on my screen. Okay? So I'm going to go back into my matrix menu. And as soon as you press that, do you see how names and A are highlighted? Just press enter. Now, what happened when you did that? It put matrix A on your screen. That's what you need. You need this on your screen. Now we need to take the inverse of it. So actually the matrix button is your inverse button. The inverse button is the button that looks like this. So just press it. Now do you see this on your calculator? Now hit times, because we want to multiply that.
It says 1, 2, 3, 6.
Well, we want to multiply it by matrix B. Now, how do you think we're going to get the B on our screen? We're going to go back into matrix, go down to B, and hit enter, and then hit enter again, and it gives you the answer to the question. It says XYZ equals what? 1, 2, 3. So X is 1, Y is 2, Z is 3, right?
I always get the wrong answer.
Well, I don't know what you got in there as your matrix.
500, 800.
It's a 3 by 1, not a by 3. This has 3 rows. This is a negative 2. All right, now, since we've gone through one together, I want you to try one with your neighbor or by yourself. Directions say solve using the inverse method. All right, so here we go. Here's a new system.
She's trying to plot
What? Why? Why are you sweating?
All right, here we go.
I'm so bad.
So what are we going to put in as matrix A? We're going to put in the coefficients. So matrix A, you're going to put in your calculator, matrix A is 3, negative 2, 1, 4, 1, negative 2, and 1, negative 3, 1. That's going in as matrix A. Now, I know you already have a matrix A in there. That's fine. Just type on top of it. Just type in new numbers. It'll be fine.
You do that all by yourself?
No, 1, 2, 3. You go.
Now, what do you type in for matrix B?
Oh, it's okay.
That's right. You type in negative 10, 4, negative 10. So you're just going to get those in there. What do you do at this point?
Now you have to go back, and we're finding we're solving.
Yeah, now you need to actually do this multiplication. So first, step 1 is get these in. You got to get these in. So in your edit menu, put in this for A and this for B. Once you get those in there, then you have to do this. So remember, these come from your names menu. So you get those multiplied, and that's going to give you the answer, boys and girls. What does it say?
Negative 1, 2, negative 3.
Negative 1, 2, and negative 3.
We're all too excited. I gotta sit on my hands, so I don't get too excited. Very mature, too.
You have to write it down.
My mom makes me sit on my hands.
Like set performance cheer.
What are you upset about?
Throwing against the wall. They're standing too late. Yeah, I feel like if I went through that,
It's nice too.
How about sharing this like all out?
All right, now, let's suppose, now this is an entirely different thing. So that's done. That problem is finished. But right now, you have this matrix in as matrix A, right? All right, let's suppose a different problem now. This is a different situation. But let's suppose that for whatever reason, you wanted the determinant of A. Your calculator will do that for you. Now, you could also do it by recopying the columns. Remember that? We talked about it last time. But your calculator will do it. Go back in your matrix menu. Now, so far, of the list of things across the top, which are names, math, and edit, we've used names. That's how you get this on your screen. We've used edit. That's how you build the matrices. Go over to math. Notice first of all, there's a ton of stuff you can do. But the very first one is determinant. So you just press it. And what do you want to take the determinant of? So you go second matrix, choose A, and hit enter. What's the determinant of this matrix? Oh, yeah, I got the wrong matrix in there. So you got negative 16?
Oh.
Easy. Now, find the determinant of matrix B. You can. Why not? It's not square. Remember, if the matrix isn't square, it has no can do. All right, now, there's another strategy I need you to be aware of.
More like quitter climb, not Katie climb.
Where's this coming from?
I don't know. I kind of hot the board the wagon.
All right, I want you now to go back to the matrix or the system that we just solved. Shoot, I erased it. But this system that we just solved, we already solved it. We already know what the answer is. But now, I'm going to ask you to solve it using Gauss-Jordan reduction. Or your book will say reduced row echelon form. Okay. Now, it's the same system. We already know what the answer is. We're just going to solve it using a different strategy. We're going to do it on our calculator using a different strategy. Okay, so it's the same system. What was the method called we did a minute ago? The inverse method. And to do the inverse method, you multiply A inverse times B, right? Now, this is a different strategy. Here's what I want you to do. For matrix A now, we're going to type in a new matrix. The matrix we're going to type in is 3, -2, 1, -10. Oh my, what am I doing here?
I don't know.
I'm typing in all of the numbers in one big matrix. This is a different strategy, so we're going to do it a different way.
3 by 4.
So now I'm going to go to second matrix, and I'm going to put in a new matrix. What are the dimensions of this new matrix I'm putting in? 3 by 4. So here we go. We're going to put them all in.
All that to one matrix. Had enough.
As soon as you get the last number in, guess what you're going to do?
Second.
After you press enter, you're going to quit out of there. That's right, you're going to go out. Now this big matrix, it's called an augmented matrix because you've lengthened it. This big matrix is now in the calculator. Okay? Now, here's what we're going to do. We're going to go back into our matrix menu. We're going to go over to math. And we're going to click all the way down until we find RREF.
Yeah.
Reduced row echelon form, RREF.
I don't think that's it.
Press enter. Yes, it is. Click all the way down.
I found it.
Press enter. Now, go back to your matrix menu. Pick A. So now the screen should say RREF A. Press enter. And this time, a big matrix comes up.
Oh no.
Now,
Just throw our calculator and we just throw it.
now, We'll do another one here in a minute. But I want you to pay attention to something. In the beginning, what did that row of numbers right there really represent? 3x minus 2y plus 1z equals negative 10. So this was an equation, right? Well, guess what? This is the same equation. Only now it says 1x, no y's, no z's, equals negative 1. In other words, what? X equals negative 1. Y equals 2, and z equals negative 3. So your answer, same answer you got when you did it before, comes out on that side.
What would you do if you started throwing like an x squared in there? You don't.
Unless they're all x squareds, y squareds, or unless all the x's are squared, we're not going to do it this way.
Okay, cool.
Now, we could do it if they were all x squareds, but not if just one of them is. Okay. All right, so now, does this make sense to everybody? That this would give an answer that says x equals negative 1? Okay, because now we need to look at a tricky situation. We're going to do the same thing, Gauss-Jordan reduction, which means you're going to use your RREF button with this system.
Yeah, I'm gonna get those.
All right, so let's take a breath here.
No, it's not.
Don't want to go too fast. Directions say use Gauss-Jordan.
I quit.
I was doing it all the time. Like, you guys have to go to
Okay. Ben,
Yes, ma'am.
say another word, and you're in the home.
Okay.
All right, I think we've had enough today.
No problem.
So Gauss-Jordan reduction, that means your book will say reduced row echelon form, which immediately tells you we're going to be using the RREF button. All right, so what do? Step 1. We've got to put a matrix in on our calculator. We're going to call it A, or you can call it something else. I always just call it A, but you can call it whatever you want. And the matrix is going to be 1, 3, 2, 6, 2, negative 1, 1, 7, negative 1, 4, 1, negative 1. And we all recognize that each of these rows represents an equation. So when I RREF this matrix, and a new matrix comes out, it will still, each row will still represent an equation. These are the x, the y's, the z's, and the equals. So I'm going to have x, y, z's, and equals when it all comes out. All right, so in we go. Second matrix, click over to edit. And once it's in, remember, and you press enter for that last entry, go ahead and quit out.
Why is there?
What do I do once I get this? Once I get this in, what do I do? So I go back into my matrix menu, go over to math, and then all the way down to RREF.
I got a couple something numbers.
And then I need to do matrix A. Now, did you get decimals? Okay, don't be concerned. Here's what you can always do. Just press your math button. Just press your math button. The very first option is frac, so hit enter a couple times. and it will change those decimals into fractions.
Oh, wow.
So the matrix that came out is 1, 0, 5 sevenths, 27 sevenths, 0, 1, 3 sevenths, 5 sevenths, and
Here's a little small set.
oh my.
What?
So math frac is how you get fractions, if you want fractions instead of those decimals. So does that look like what you got? And I need you to look at that carefully. That looks a little different than the last one looked.
Yeah, why?
Yeah.
Yeah,
They're all
because the
zeros.
last one, yeah, that's the problem. The last one, oops, the last one looked like this. I can't remember the numbers, so I'm making these up. But something like this is what the last one looked like. So the bottom row, let's go to the bottom row. It said no X's and no Y's, but 1Z equals 3. That's what that bottom row said. So we knew Z was 3. What does that bottom row say? It said, what does it say?
0.
It says, it literally says 0Z equals 0. That's what this bottom row says. Now tell me about that.
Clear.
What is Z? Actually, it's the opposite of that. Couldn't Z be anything? I mean, 0 times something is 0. What could that something be? Anything. So we handle that by saying Z is Z. So you want Z to be 12? Okay, Z is 12. Now, what about Y? What does this equation say? Now remember, this is the Y, this is the Z, and there's an equals there. So Y plus 3 sevenths Z equals 5 sevenths. That's what this equation on the calculator says. So Y equals 5 sevenths minus 3 sevenths Z.
That means that can equal anything.
Now, don't worry about that. Remember, what is Z? Anything you want it to be. So if you want Z to be 12, then okay, Z is 12. And can you find a Y value then if you let Z be 12? Yes. Now, I let Z be 12, I get a Y value. Maggie lets Z be 10. What happens to her Y value?
Changes.
It'll be different. Could you all get a different set of answers? Yes. And what does it depend on? What you pick for Z. Right. What about X? What's that equation say about X? X plus 5 sevenths Z equals 27 sevenths. So what does X equal? 27 sevenths minus 5 sevenths Z? You okay with that? So there are infinitely many solutions to this problem. Here's what's happened. These equations that we've been working with today, these are equations of planes. So like the ceiling and the wall and the floor. These are equations of planes. The first couple problems we did where we got an answer like 1, 2, 3, X was 1, Y was 2, Z was 3, that means all 3 planes are coming together in a single point, like they do in the corner of the room. This situation is different. It means all 3 planes are coming together in a line. There are infinitely many solutions, all the points on the line, because these 3 planes are coming together like this. They're coming together to form a line. Do you think it's possible that I could randomly pick 3 planes and they would not have any common intersection at all? You see it all over in this room, right? The floor, the ceiling, and that wall do not have a common point of intersection. So what does that matrix look like when that happens? Okay, so we talked about 2 scenarios so far. if we get something that looks like this, then that clearly says that's the point 1, 2, 3. If we get something like this, then we know we're gonna have this infinitely many situations. We'll practice another one of those. If you get this, when you RREF it, if you get that, then you've got no solution. Can you tell me why? What would that equation say? 0z equals what? Tell me about that. Can 0 times z equal what?
Makes sense, makes
So
sense.
that would say there's no solution. This would be an empty set. There are no points in common. This situation, that is possible, right? Infinitely possible. So we got all this mess. We'll practice that right now. This is best case scenario. You just get x equals y equals and z equals. All right, so let's try one more. I'll give you a little bigger one this time. Not that it matters because you're doing it on your calculator, so it really doesn't matter how big it is. But here we go. A plus 2b plus c plus d equals 3. 2a minus b minus 2c plus 3d equals negative 1. 3a plus b plus 4c minus d equals 4. 4a plus 3b plus 5d equals 5. Here we go. Your job is to use Gauss-Jordan reduction, which is the same as RREF, reduced row echelon form. So, Mackenzie Wiseman, what do I do first? Exactly. Put them all in an augmented matrix, which I'll call A, but that's, you call it whatever you want. We're going to make one big matrix consisting of every number in this problem. So 1, 2, 1, 1, 3. 2, negative 1, negative 2, 3, negative 1. Got to be real careful here about getting negatives and stuff. Whoops. What about this bottom row? I got a 0 for the C spot. That happens a lot in the big systems. Just put zeros in if you have a letter missing. What are the dimensions of that guy? That's a 4 by 5. Know what to do once you get it all in there? We quit, right? And we go back in. And what do we need to do? Over to math and reduce row echelon form. And this one came out decimals and they're not bad, so if you want to keep the decimals, that's fine. If you want fractions, you can change it using math frac, remember? By the way, that works for everything, not just matrices. You can always math frac. Okay, that is, you're going to use your calculators and your homework tonight. We're not quite done. Now we gotta write our answer, right? So we start at the bottom, and what does that bottom row say? Z equals Z. And then we build up from there.